Dividing rational expressions is very similar to multiplying them. The only difference is when we're dividing a fraction, we need to multiply it by the reciprocal. So what that means is we're going to start with our first expression, 5n to the fourth over a negative 2. But I'm going to change my division sign to times, and then I'm going to flip over my second fraction, giving me the reciprocal. Now from here, I can look at anything that I can cancel from the top and anything that I can cancel from the bottom. So I've got a 5 on both, so I can cancel out a 5. I've got n to the fourth on top and n on the bottom. I can cancel out n to the fourth and n, and I'm left with n to the third. The final thing I can cancel is the negative 2 and 6. So if I cancel out the negative 2, that's going to leave me with negative 1. If I cancel out the 6, that's going to leave me with a 3. My final step is multiplying everything on the top and everything on the bottom together. So n to the third times 3 is 3n to the third. On the bottom, I'm left with a negative 1, which I could also just write as negative 3n to the third. In another example, I already have some factors here. Now, when I'm doing this, I need to make sure that I'm not canceling anything in the first step. What I need to do is I need to change this to a multiplication question. So I've got 2 and then x plus 1 in brackets, all over 3x. I'm going to change it to a times question by flipping over my second fraction. So I've got the reciprocal on this side. Now when I'm canceling, I need to look for factors that are exactly the same or something I can divide out of both of them. So x plus 1 is exactly the same factor. I can cross off the whole bracket. But I can't cross off the x individually, and I can't cross off the 1 individually. It has to be the entire factor that gets canceled. Over here I've got an x and an x I can cancel out. I also have a 4 and a 2, and when I divide that, this is going to become 2. So on the top, I've canceled everything except for the x minus 2. On the bottom, I've canceled everything except for 2 times 3, which is going to give me 6. Now I need to indicate non-permissible values. In non-permissible values, I need to look in 3 places. First of all, I'm going to look in the denominator of my first expression, and that tells me that x cannot equal to 0. Then I'm going to look in the denominator of my original question. So here I already have x cannot equal to 0. I can always also say x cannot equal negative 2. And finally, I need to look in my flipped over version, which is going to tell me also that x cannot be equal to negative 1, because negative 1 plus 1 would give me 0, and we know we can't divide by 0. So my non-permissible values are 0, 2, and negative 1. Now in this example, I'm going to need to factor. So I'm going to flip it over first and change it to a multiplication question. So I've got 4x minus 10 equals x plus 3 times 2x squared minus 18 over 12x squared minus 60x plus 75. Now everywhere that I can, I'm going to factor. So in this first expression, I can factor out a 2. So I'm going to get 2x minus 5. And the x plus 3 can't be reduced, so it's just going to be x plus 3. Now on this side, I can go 2 and then x squared minus 9. But we know x squared minus 9 is a difference of squares, so I'm just going to erase this, x squared minus 9, and I've got x plus 3 and x minus 3. So when I factored out the 2, that gave me a difference of squares, which I could then factor down more fully. Now in this bottom one, I can divide by 3. So if I divide out a 3, I'm going to be left with 4x squared minus 20x plus 25, which when I factor it can give me 2x minus 5 and 2x minus 5. Now I'm going to cancel out terms that are identical. So I've got 2x minus 5 I can cancel out. I've got an x plus 3 I can cancel out. And that's everything that I can cancel out because there's nothing else that can go out of the top and the bottom. So now I'm going to multiply. 2 times 2 is 4, and I'm left with x minus 3. On the bottom, I've got 3 and 2x minus 5. Now I could continue to expand that if I wanted to and get 4x minus 12 over 6x minus 15 if I chose to. Now I need my non-permissible values. For the non-permissible values, I am looking here, here, and here. So because it's a division question, those are the things that were at one point on the bottom. So my non-permissible values from my first expression is going to be negative 3. From this one is going to be negative 3, which I already have, and positive 3. And from the bottom, it's going to be 5 over 2.